Thanks for plugging in. Today we're talking excellence with TE Connectivity and the interconnect specialists from TTI IP&E. It's the news, information, and detail you need to know to stay informed about the latest innovations in all types of electronics connectivity. And now, here's your host, TTI's Scott Stemley.
Thanks, Jim. Hello, everybody. Great to have you tuning in to our next series, Talking Excellence with TE and TTI. In the studio with me today is TTI's Gabe Osorio, the Director of Transportation Marketing for the Americas. And with us today is Bernard Vetten, Senior Principal Field Application Engineer for TE Connectivity Automotive. Thanks for spending some time with us today, Bernard. Would you please tell us a little bit about yourself and your career at TE?
My name is Bernard Vetten, Senior Principal Field Application Engineer on the West Coast for TE Automotive. Had quite a journey with TE, originally from the Netherlands. I have multiple different business units as experience under my belt, been in 3 different continents, and have been focusing on automotive for the last 10 years on the West Coast, where we work together with customers developing the latest technologies.
Very good. So we're going to jump into EE architecture and some of the innovations in vehicle connectivity. So the first thing I want to kind of dive into are, what are some of the biggest challenges in the industry today when it comes to enabling next generation EE architecture?
We've seen significant changes in the automotive industry over the last years. Early movers in the automotive industry have taken the opportunity to reimagine some of their vehicle architectures, really taken a note out of the consumer electronics playbook. Vehicles are fully upgradable with capable hardware to be able to connect over-the-air updates with an ever-increasing feature set, both on the infotainment content, assisted driving features, this all to stay in line with the customer expectations, as seen in the consumer industry. This ever-increasing content is driving the need for EE architectures to be able to support not only the power consumption, but of course also the data requirements moving forward to support all these infotainment features and driving features. It's a very exciting time for us with all these changes. We've seen changes happening, of course, on the sensing suite, on the wireless connectivity coming into the vehicle, all the way down to the zonal controllers, the ability to have the vehicle functions all centralized in only a couple of boxes instead of over 10 or 20 ECUs. Moving forward, so exciting time to be in the automotive industry, and we're facing these challenges and enabling the next generation EE architectures moving forward.
Yeah, thanks, Bernard. Quick question or a follow-up question there. Does the increase in the features or the different EE architectures drive further design constraints or considerations in terms of getting all those new architectures or new technologies to communicate and work together in a vehicle?
It's definitely driving more and more challenges all the way, and I can compartmentalize this in, for example, on our just low voltage data. We see a challenge where there's width miniaturization requirements because of the ECUs are also shrinking in size. We see just challenges to make sure that all the signals will still fit within not only the box, but also in the connector and in the harnessing. If you move over towards the data, we see challenges of now having so many different data ports and data buses where we support the customers with products which are shielded sufficiently enough to make sure that there's no EMI or EMC harsh environments, and are covered for any of the internal emissions, but also the external emissions we nowadays see around the vehicle. And all the way up even to having power backbones to be able to feed some of these more centralized ECU controllers, as they of course are starting to use more power, and making sure that they are ready for the upcoming hardware increases moving forward.
Yeah, that's really interesting. Thank you for that. Shifting gears just a little bit, or maybe even going a little bit deeper here, specifically around high-speed data transmission And I would imagine, with all of the increasing technology, cameras, LiDAR, radar, et cetera, that are showing up on vehicles or becoming a part of the network of vehicles, and the demand for high-speed data transmission, what are some of the emerging, innovations that are coming out or that you're seeing that help ensure reliable or secure communication for these complex systems?
And we've been working on products for quite a while. Of course, we have an extensive portfolio already available, and we're working very closely together with our partners to make sure that we can meet all these requirements on high-speed data transmissions. Within TE, and also me personally being on the West Coast, we very closely work together also with our chip vendor partners, moving the protocols and the standards which they're promoting within the industry. And it actually has been quite a flurry over the last years with proprietary protocols, but also upcoming standardization bodies to have an offering in combination with, for example, serializer, deserializer, together with a connected product. So we've seen the speed requirements moving upwards. Not only because of for example, the sensing need, but also some of the displays, sometimes moving just the over-the-air data, as we talked about earlier, towards the high compute module, but also towards the rest of the system ECUs. And here we're working together with these partners to make sure that we collaborate and have a go-to-market strategy together. For example, we did partnerships in the past with Texas Instruments, and here we just want to make sure that the customers see us as a one-shop stop where you can get your products for the automotive market in combination with whatever desired chipset or protocol you would like to connect your ECUs within the vehicle assemblies. In addition to some of these new trends, miniaturization is still a real need. We have seen some of the challenges to just package. So in addition to some of these new developments, we came out with new product series, for example, as a Matex for coax and Gemnet for differential signaling, just to make sure that we have the product out there for the upcoming product needs and product speeds the OEMs will need in the future for their vehicles and their vehicle lineups.
Yeah, that's really interesting example. Do you see the further growth or expansion, at least in terms of the size of data that needs to be moved around in the vehicle? Because it seems like that's something that continues to grow in terms of what a customer design might be looking for based on the number of new technology showing up on a vehicle in term just in terms of data package size and how to quickly move it to a computing center from a device, et cetera. Is that something that will continue to see growth, or do you think we're leveling out from that perspective in terms of data size that's being asked for from a customer base right now?
Definitely see growth in that industry in general, but also just in the package size. It does have to do with the combination of the architecture. For example, if you're a centralized or distributed architecture, you would have different requirements. So we do see the speed still going up, even on the sensing elements, all the way up to 8 megapixel and beyond. It starts to become more and more of a standard in some markets, especially Asian markets, but also high-end products here in the US market. In addition, displays are really driving also more and more content, and depending on the application of the display, for example, if it's safety critical or if it's more infotainment driven, there are different latency requirements. So we do see a mix between the product offering as needed. Sometimes we offer products in combination for daisy chaining with some of these high-speed data connectivity. In other products, we want to have a point-to-point connection as it's more critical or safety critical, and we want to make sure that there's no latency aspect to it. We offer both, but yeah, keep a close eye on it, and yeah, definitely still the content is increasing, the speed is increasing, and not even talking about the Ethernet backbone, which is also becoming more and more popular, where we offer products not only on the discrete side, but also products if you want to possibly integrate into ECUs.
Great, thank you.
So, everything you've just been talking about for the last few minutes, Bernard, is going to require power. So, powering the HPCs, can you explain the role of robust power supply solutions for these high-performing computing platforms?
Yeah, no, definitely. And here, take one step back. I think it's really a battle of efficiency. The redundant power supply into an HPC is very critical, especially if we move more and more functions within the high compute. It's of course especially critical to make sure that there's no power outage, there's no redundancy. If you add, for example, even driver assist features or even beyond self-driving features in these vehicles, you want to make sure that not only you have the redundancy, for example, on the compute, but you also want to have the redundancy on the power. In addition to that, we start to see quite interesting architectures out there where not only on the high compute, but full redundancy is needed as you start to add more and more safety critical components in these function sets. So it's still always a function of the module if it's safety critical or not for power redundancy. We offer multiple solutions depending on the needs of the customer. Interesting trends we start to see, especially again moving towards this high compute, because also high compute is also high power. So quite often they have a significant power consumption, and there are different ways of solving at least the power demand. Of course, we can go up in current, but other options we see out there in the market nowadays would be if you would go up in voltage. You're able to move away from your 12 volt to your 48 volt bus, where you have a reduction of the current draw to get the similar power outage, and this gives you an option to reduce at least the overall connector size. You built in other feature sets to be able to get that. To get the overall power, and here this helps with the redundancy, as quite often we nowadays see that there's two input powers into any of these controllers as they are safety critical, and there is an additional split even in the modules that there is a redundancy, especially if you, for example, start to talk about driver features, where if there would be a failure either on the input power within the module, the other half of the PCB, for example, could take over and still get you to a safe stop, or at least get you to a safe manner to move forward.
Mm-hmm. Okay, perfect. Thank you.
Yeah, that makes sense. And I think that kind of leads perfectly into my next question, Bernard. It's around the mixed and modular connectivity or connectors. Obviously for power and for the signal that's taking place with these new these new architectures, how are mixed the mixed modular or really hybrid connectivity solutions contributing to help make these new architectures more scalable, certainly within these modern transportation systems nowadays?
Yeah, and actually almost want to add a part in here, because of course the mixed modular connectivity is a key driver of flexibility and scalability. But another important driver which people don't often discuss about, and especially if sometimes we get engineers at customers which are moving in from other industries don't always understand, is some of the challenges of actually assembling some of these connectors at the vehicle assembly plant. So in addition to this increased electrification, as we talked about it already earlier, with, for example, the ever-increasing sensing suite, the ever-increasing infotainment options within the vehicle, the antenna arrays which the vehicles are offering, we see a spike in data ports coming into any of these ECUs. And with that, just the sheer amount of connectors coming into one specific high compute controller can easily go above 12 connectors. And we start to see issues at the assembly plant where even ergo rules, or even to be able to hit your cycle times for making some of these connectors, start to become a challenge. And we see an additional offering there with some of these mixed and modular connectivity solutions to be able to of course increase per individual connector the port count, but reduce the overall connector count in the ECUs to help the operator, for example, instead of 12, made 4 connectors or even 2, and they're really helping their ergo their cycle time, and some of these complexities. Of course, integrating all these connectors into one have other challenges. Some of it we solve by having different modules with different connector options within these modules. This could be all the way from our low voltage offering, so for signal, all the way up to mid power, high power, and then some of the data products. One of our products offering there is MHS, which is a modular hybrid system, really targeting not only that flexibility for offering all these different inputs into controllers, but also is automation ready, which is another big push we have within the industry, is to rethink the harness making process and then trying to improve that in general, so that we can go to a higher level of automation, as manual labor is a challenge, and not only a challenge, of course, to just ramp up, but an additional also challenge to make sure the quality is there. So it's highly driven by the quality aspect of it, really moving forward some of these products. Other offerings what we've been targeting is really just to increase the data content. We will have a product which would focus on the total port count, and then you can really reduce and then customize. So we try to offer both a flexible solution where you have kind of building blocks versus a customizable solution where you would target the multiple port counts, and of course then help that vehicle assembly, but also the operator on the production line.
Yeah, that's a great point on the production assembly side of things. A lot of times you don't even think about that. Yeah, it's always the architecture design itself and not necessarily the actual building of it. So yeah.
And Bernard, that everything you just described, could not only apply obviously to pass car, but construction vehicles, off-road vehicles. They would all benefit or are moving towards that same same modular technology, if you will.
Yeah, especially in our organizations, we internally we call them industrial commercial transportation, which is on highway, off highway transportation. We see very healthy overlapping in the products, but not only the automotive products. For example, if you're on highway, if you think about semi-truck, you can have, for example, the connectivity products within the cabin, very similar as automotive, but because these vehicles are quite a lot larger than your typical automotive vehicle, even including some of these pickups, they do have completely separate lines for some of their individual needs. And especially also if you start combining it with on highway, but also off highway, where nowadays great examples are there. If you ever have the chance to visit the CES show, what John Deere is putting out there at CES with some of their latest equipment, they're full of sensing sets, and really just to help the off-highway market there. So it's a combination. We do offer additional products in that field because there's an additional level of robustness required. These products are typically their downtime is a lot less than what you see in automotive vehicles versus what they expect on highway and off highway. And then just because of the total equipment cost and just the size of the equipment, we have different product offerings. So some of these examples are MCL 16 coax, the Deutsch high speed, DT high speed, and some of the HDSCS series, which are already very known in the market, but offer this solutions for either adding Ethernet, adding camera connections, or even the antenna connections. So it's an overlapping industry. And we're all working towards the same goal.
Excellent.
Yeah, it's incredible. It seems like even those applications might have the opportunity for even more, more architectures or more technologies coming into place when you even start to think about seeders and GPS location of seeds and, all of the construction vehicles and leveling off of, whatever they're working on. And it just seems exponential in terms of what the growth can be there. So thanks for that, Bernard. It all kind of helps me, think about something that the salacious news stories that you might see on TV that a hacker hacked my Jeep Grand Cherokee or something along those lines, right? Can you talk a little bit about cybersecurity within the connectivity of these emerging architectures, right? And how's the industry balancing between the growing needs of those architectures and ensuring safety, right? Cybersecurity across these diverse vehicle types.
Yeah, and as you mentioned, it becomes more and more critical, and some of it is driven still by possible standardization. But yes, there are ways to, for example, even spoof sensing elements or even the GNSS antennas. All of a sudden, your navigation thinks your route is, for example, towards the grocery store, and all of a sudden you end up some back alley in downtown. That is still all possible. Most of these solutions are still driven highly by the hardware and software side. So there's different handshakes happening within the industry. Definitely on the connectivity side, we have the capability of building it in. So with some of the smart connectivity solutions we are offering in other industries, there would be more of a handshake. So for example, after mating a connector into, let's say, a radar module, the product will do a handshake if this is the connector it was lined up to do so. Having that said, for us in automotive, it's still limited as a functionality within the connectivity side. So it is a focus of the industry. They always look at the holistic system level and where does it make the most sense to integrate. So we see these integrations happening on the ECU level. We see these integrations happening on the software level. But at this moment, it's very limited still on the connectivity level. And yeah, then we keep an eye out on it, and also we're definitely interested in some of the spoofing options out there. For example, some of these sensing elements are quite external to the vehicle. As an example, radar modules are nowadays placed in the front fascia of the vehicle. What if you would replace that with another radar? Could you get access to the vehicle level? So we keep an eye out on that as a feature set, but until now, all these controllers individually have to be married into the sensing suite, which is still an additional step. So you cannot just swap out a sensor, in this case a radar sensor. It still needs to be recognized by the system to first be accepted as a valid input.
Yeah, it's fascinating.
Well, Bernard, we certainly appreciate your time today. Great insights, lots of interesting dynamics to consider. As we look at the architecture of these new vehicles. So again, thank you for sharing your insights and for your time today. Before we close, are there any additional comments you'd like to make to our audience?
Oh, not directly. I'm happy to have this opportunity, and it's an exciting time in automotive. Definitely feel this is an industry with a lot of change happening, all the way from over-the-air updates, the zonal architectures, the software-defined, the high level of integration. So I still feel also there's going to be an additional consolidation happening. For example, on the antenna architectures, the automotive industry is on the verge of change, and it's fun to be a part of it.
Yes, it is.
Couldn't agree more.
Yep.
Thank you very much, Bernard.
Well, thank you to our listeners for plugging in to Talking Excellence with TE and TTI. You'll want to press play on our next episode of this series with TE Automotive. Until then, have a great day.
That's it for this episode of Talking Excellence. Join us next time for the podcast that brings together the specialists of TTI with the connectivity experts from TE, an insightful conversation about getting connected.